Hello, this is CathalRyan. My student number is 2134088. Today I'll be going through the wind turbines operation. So here are the systems we explored. So you have the types of windmills and their applications, and you have the components of a windmill and how they function, and the efficiency and the environmental impact. So in this slide we have the types of windmills. So we have the traditional windmills and we have the modern wind turbines. So in a traditional windmill, they've been used for centuries for grinding grain and pumping water. They rely on large wooden blades and a central shaft to transfer kinetic energy into mechanical work. As in the modern day, these aren't seen as much as the modern wind turbines, which generate electricity by converting wind turbine into electrical power through a generator. These turbines can be onshore, land-based, or offshore, sea-based. Horizontal axis wind turbines, most common, high efficient, and can be very large, and the vertical axis wind turbines can operate in different wind directions but also generate less efficiency. So here we have the key components of the windmills and their functions. So the blade and its function is to capture the wind and rotate the shaft and transfers rotational energy from the rotor to the generator. The rotor converts wind energy into rotational energy. The generator converts mechanical energy into electricity. The nacelle houses the generator in the gearbox, and the control system adjusts the blade angle and monitors the wind connections, and the tower supports the turbine at optimal height. So here we have the gear system in a windmill. So the rack and pinion is a type of linear actuator, consists of a circular gear, the pinion, that it meshes with a straight toothed component, the rack. This mechanism enables the conversion between rotational and linear motion. The 90-degree configuration enables torque transfer between two perpendicular axes through rotational motion. These gearboxes are compact, efficient, reliable, and last long. So here are the pros and cons of a windmill. So the pros: renewable and sustainable energy sources. It reduces dependence on fossil fuels, low operational costs once installed, and no direct carbon emissions. The cons are a high initial cost for installation, intermittent energy production, depends on the wind availability, and can cause noise pollution and affect local wildlife. And I just included a picture of pros and cons of wind energy to the side. Here we have primary research. So experiment is measuring wind energy efficiency. The objective is to investigate the effect of wind speed on a turbine efficiency, and the method is to use a small wind turbine model and measure energy output at different wind speeds using an anemometer and a voltmeter. Compare blade design straight versus curved and record energy output. And the result: collect the voltage and current readings at different wind speeds to determine which blade design is more. My final thoughts: I've gained knowledge about the various kinds of windmills and how they produce energy by finishing the CBA. Despite their increased efficiency, modern wind turbines have drawbacks, including expense and environmental effects. My understanding of a variable influencing wind turbine efficiency has improved as a result of study and experiment. With technological developments, wind turbine or wind energy, a promising renewable resource, could become even more feasible to meet the world's energy demands.